Okay, the next thing I want to do is just tidy up the notebook a little bit because we're doing several things in this one. So at the top, I sometimes do these later. I'm going to add in heart disease data. And this was just to kind of get a quick score. I honestly didn't know how it was going to perform. It's kind of cool that it outperformed our tuned decision tree. And then I'm going to put this as a subheader within it. Okay. Because now what we're going to do, and it is worth making the note here since it's, we'll forget the words that I say. I'm sure that the recordings are here, but, this outperforms our tuned decision tree from the previous lecture. Okay, that's just really cool. Okay, so now what I want to do is I want to look at a different data set. And what I have is the code. Okay, I have some starter code for you. It's in the DF Census Prep Colab notebook. And you can just copy that and you'll see why. Okay, so if I copy this in, go ahead and copy it in and put it into the random forest One Hot Encoder. You could also just go with that one if you want to make your own copy. All right. Oh, before that, we're gonna switch the data set. So I'm gonna do a new text cell and give it a new header. This is our census data. All right, in this part of the lecture, we're gonna look at One Hot Encoding. All right, so when I put in that code, right, this is the census data. We've looked at this before. From the UCI machine learning repository, you need to put in the column names, and then we just drop that education column because it's extraneous. And so now I look at it. Here we go. This should look familiar. Each row is also a person here, gives data on this person. And we're trying to predict whether the income is greater than or less than 50K, right? So recall that what we did before is PD get dummies, okay? I just like, I don't know that I want to reassign. Let's say DF, this is DF census, okay. So DF census, I'm trying to think what to call it, like dummies, it just sounds kind of weird. Whatever, let's just look at it. I think because we're not going to keep it. Well, actually, I want to check some things about it. Okay, so let's just whatever, df.dummies. And then it's pd.getDummies, dummy variables, that's the point of the word, df census, okay? And let's just look at how it's different and recall how pd.getDummies works. All right. So you can see it's turned the categorical columns into numerical columns. And we have to remember the issue with having a duplicate of the last column. So here's what I want to check. I want to check the shapes of all these different data frames. Okay, so what's the shape of the DF census? Actually, we could start even with the first one. What is the shape of the heart disease? So what this does, it gives you the number of rows and columns. Look, 313 rows, 14 columns, that's little. Okay, now let's try DF census. If I do the shape there, this is a bigger data set. I've got 32,000 rows plus and 14 columns. Interesting, these are both the 14 columns. And then DF census dummies, that's our final one. And what is the shape here? Well, you get now 94 columns. So that's a significant difference. It's almost a factor of 10 greater, okay? Because when what you want to do is you want to look at the total number of entries, right? The entries are the rows times the columns. And by the way, if you wanted to see that exactly, note that this is a tuple. And so if you have a tuple, you can take the first element using bracket notation and then multiply it by the second element, like the 0th and the first. And that'll tell us how many actual entries there are. And you can see it's 3 million. It's a lot. Okay. And furthermore, right, like, so if I copy this and say, hey, Well, I'm building a random forest. Well, a random forest is times 100 decision trees. And then that's also times, with cross-validation, really I'm doing that 5 times to get the 5 different scores. And what do I end up with? Look at that. That's huge. It's hard to even see it. There's 3. Wow. That's over 1 billion entries. Okay. And so this is when we get into the world of big data, right? I think in this day and age, big data, in my mind, like really big data, is like over 1 billion rows. Yeah, maybe hundreds of millions counts, but like thousands of rows, and not that it's not just rows, right? Because we're talking entries. Because hey, you could have 1,000 rows, and but if you have 100,000 columns, that's a different story. So this shape allows you to get the size, and it's going to matter. I tend not to worry about it too much until I see like models taking too long to run, and then I know I need to make changes. But once you enter machine learning ensembles, again, we've got two orders of magnitude greater, right? Like 100 models. It matters. And here's the deal. If you look at this data set, there's so many zeros, right? And it's because that's what PD-Get-Dummies does. So there is a solution to this, and it's kind of simple. You know, somewhere along the way, people said, well, what if we only store it when there's a positive value and we ignore it when it's a 0? That's what One Hot Encoding does. Okay. And so it's called a sparse matrix, and it's really going to cut down on the number of, and that's the goal, at least, the number of, data points. So let us now look at how to implement One Hot Encoding. Okay, so let's do a new text header and call it One Hot Encoding. All right, and how do we do it? Well, okay. There's an issue. So PD-Get-Dummies is nice because like it only does this for the text columns, but by default, the One Hot Encoder will actually do it for them all. So here's the issue. Like if we One Hot Encode capital gain, this is going to be a terrible idea. Like imagine even it worked with PD-Get-Dummies. Same bad idea, because why? Well, then like you're going to have, okay, who has 2,174 of capital gain? Well, only this person's going to have a 1, right? It's always going to be different numbers. And it's better in a machine learning model if we treat these clearly as the way we normally treat numbers, that, if someone has 2,173, it's not just different, it's actually very close. And we want to keep that column as it is. Okay, so we only want to One Hot encode certain columns in this case. That actually makes it a little more challenging. If you want to, like if you have it's all text, it's much easier to do. Okay, so let's just go through in this example how we would actually do it. All right, so first thing first, we need to import the One Hot encoder. So it's from, no, what's interesting here is it's from sklearn.preprocessing. And the reason why is because it's designed for as a machine learning technique. So then you import One Hot encoder. There it is. It's always nice when you see it, when it's new. Okay. Now, in order to use it, you would just initialize it. It says this is new code here. I'll go through like the steps. So import One Hot encoder. Right. We can initialize it because sometimes it's abbreviated OHE. It's just like you just write maybe OHE, and then you write in One Hot encoder, right? Parentheses. Okay, but again, before we actually, we'll go ahead and run that. Works. Okay, before we actually do it on the data, we've got to be a little careful. That was my point. And so here's the strategy. if you look at dfcensus.info and we look at the column types, do you see how they're labeled, like the D types? The ones that we want to change are actually the objects. Okay, you see that? We want to change the objects. So we can write code to do that. So let me just clarify what I'm doing here. We're going to view column types. And what we're basically doing, why are we doing this? Well, I'll make it the comment after it, I guess, in a text header. So note that, well, object D types are the ones we want to change. Okay. So how do we do that? Well, let me show you the code for it. It's not something I would expect you to know. Okay, I'm going to call it the categorical columns because that's what they are. They're categories. You could call it something. You could call it object columns. Maybe that's better. It's called object columns. Object is weird because I don't know why they call it that. Like they're basically strings. But there's usually good reason for things that can get very technical. Okay, so how do we do it? Well, df census. So what we're doing, we're just making a list of these columns only, okay? So let me state that before I get all the code in here. So make list of columns of D-type object, right? Not too complicated, really. So it's just the way you write it. Then you've got to write, okay, so here is where I pick the columns. And it's df census, right? Dot D types, okay? Note there's a plural there. We want those equivalent to object, right? And then finally, what we want to do to convert it to a list is you actually want to write to list, okay? So that should do it. We can run it to make sure it works. Got an error. Let me double check code I have. What does the error say? Unalignable Boolean series. Let me check my code for this. Oh, I see what it is. I left off dot columns. Okay, yeah, because yeah, that's like trying to. Why? We just want the columns. We don't want the data inside of them. So let's try that again. There we go. Always nice when the errors disappear. Okay, so that's just a list, right? It's not really that big of a deal. But now we can actually, what we're going to do, see, let me show you, like to, I don't know, let's say like data frame of, we're basically going to narrow down the data frame. Data frame of object columns would be then what? It would be, it's kind of simple. It would be just df census object columns. Because see what we're doing here is only selecting the you know, right? Like this is df census. Well, what columns do I have in here? Well, it's the list of the ones that we just defined. So let's try that, see if that works. Yeah, do you see that? How it's all basically the text columns now? Okay. Now you might wonder, why are we doing it like this? Well, it's because we're going to one hot encode just this, and then we're going to combine it with the rest of it. And you know, again, this is a tricky little piece if you're only one hot encoding part of your data frame. Okay, so we're basically ready now, and what we can do is the following. We can you know, one hot encode object columns. Okay, so what do we put in there? Well, I like to say now hot. So it's hot, folks. So now we do the OHE. That's our one hot encoder. And here's the code. It's fit underscore transform. Okay. And then you do that on the DF object columns. Sorry, DF census. All right. And then if you want, we could just look at it too. Like if we print it out, what does it look like? All right. Look at this. Beautiful. Okay. So first of all, you may be perplexed as to its look. Like, wait, why does it look like this? What this means, this is row 0, okay? And these are the column numbers. See, it's only showing us when it's a 1.0. It's skipping over all the zeros, okay? So this is one hot encoded. This one hot encoded, okay? And I know it's hard to kind of like get it to match, but you can do it. I'll show you the code for it. So what I mean is this. What we're doing here is we're looking at one hot encoding in a thorough way, actually. And so I want you to see how it would look in terms of the actual data frame. You wouldn't necessarily want to do all these things when you're just building a machine learning model, but I want you to see what one hot encoding actually does and how it would actually compare. So what I can do is this. I can do a hot data frame, and I can do pd.dataframe. Okay, so I'm trying to convert it into a data frame now. And then I take hot, which is what we just have above, and you can do this dot to array. Okay, that's what you need to make it work. It's like on a list, like a list kind of, but like, you know, it's more like a NumPy array. And so now if I then do the hot df.head, okay, that should show the first 5 rows of the data frame. Let's say what we're doing here, okay? So we're converting converting hot, the one hot encoded, data to traditional data frame. Okay. Okay, I want to show you the comparison so you can see what it looks like. See now, do you see how this works? Now you've got all these zeros because it's only showing up when there's like look at, see, here's the 7th row. So this has everything. That's not what we want actually. We want this, the one hot encoded one, which only shows it, if I scroll up, the first row. So it's only encoding the 7th column, the 13th, and the 17th. So get the 7th column, the 13th, the 17th. Those all show at once. Isn't that cool? So that's the one hot encoded. Now there actually is another piece left, because note that even though we do it like this, we're missing a lot of the data, okay? So how can we go back and get the rest of the data? Let's do that next.